Welcome to class. In today's class, we're also going to be solving one of the Waec past questions, and it's on inverse variation. Okay, so the question is Q varies inversely as the square of R. Okay, if Q equals 12 when R equals 2/3, find Q when R equals 6. Okay, so the first thing we're going to be doing now is to form an expression for our question. But do not forget, if this question were to be Q varies directly as the square of R, it should have been with this. But our question is not Q varying directly as the square of R. So we are going to clean this. But don't forget that inverse means the reciprocal. Okay, so I'm going to write this now. Q varies inversely as the square of R. So I'm going to be making do with this expression. Are you following? Good. All right, so the first thing I'm going to do is to find the value of my constant K. Without the value of my constant K, I would not be able to solve this question further. So now let's move ahead. So I'm going to be using the first set of values of Q and that of R to get my K. All right, so let's find my K using Q. I'm going to be substituting now. So let's find my K. 12 with the value of Q, okay? K, R squared. My R is 2/3. So I'm going to square it. Are you still following? Okay. All right, so there's something I want to do here and I want you to pay attention. Now, 2/3 squared, that means the squares affecting both the 2 and the 3. By now, you should know. All right, so 2 squared means 2 in 2 places. 2 in 2 places, that is 2 times 2, 4. And the 3 squared does not mean 3 times 2, okay? It means 3 in 2 places. 3 in 2 places, 3 times 3. And this other one is 2 times 2. So please do not make that mistake. Don't get tempted to say 3 times 2. 3 squares, 3 times 2. No, it is 3 in 2 places. 3 times 3, 9. All right, so that will give me 9. Okay, are you still there? Good. All right, so we're going to move ahead. Now, I want to do something, so I want you to pay attention. Now, this is 12 equals K. Now, this K is on top as the single numerator, while 9 is the denominator. So I'm going to split them. Look at what I'm going to do. I can decide to say K over 1. Okay, this line here means divided by 9. Now, this one and the expression here can also be written as this. Okay, so don't get confused. It can also be written like what I've written here is the same thing what I have here. Are you getting it? Fantastic. So I can say 12 equals K over 1. Now, do not forget we do not divide fractions. Rather, we do what? Multiply. So at this point, division will change to what? Multiplication. And when it changes, there will be a swap of positions. So that means 9 will go up and 4 will come down. So now the new fraction here will be what? 9 over 4. That is 9/4. Are you still there? I hope you're following. Good. So what I'm going to do, I'll be 12. That is 12. 12 equals K. 9 times K is what? 9K. And then 1 times 4 is what? 4. So I'm going to make this one to look like a fraction. So what am I going to do here next? I will cross multiply. Okay. So 4 times 12 is what? 48. And 9K times 1 will give you what? 9K. So what do we do from here? I believe you can easily guess, right? Yeah, we're almost done with this part. So we're going to divide both sides by the coefficient of K. And the coefficient of K here is what? 9. Divide both sides by 9. Now, obviously, 9 is not a factor of 48. 9 is not a factor of 48, but there's also another factor that can go in 48 and also 9. So that will be common factors. So then, but let me cross out this 9 here 1, 9 here 1. And what is that factor? That's 3. 3 can go in 9 3 times, and 3 can go in 48 how many times? 16 times. So that means I have the value of my K to be 16/3. And that is 16 over 3. So now with this, I'm going to substitute this value of K, the constant K, into this. Okay? So that will be Q equals K. What's the value of my K now? 16/3. That is 16 over 3 divided by R squared. So I'm going to do the inverse. That will be multiplied by 1 over R squared. That's multiplied by 1 over R squared. Are you still following? So that will be Q equals 16 times 1 is what? 16. And 3 times R squared will give us what? 3R squared. Now this is the formula connecting all the terms in this question. So this is what I'm going to use in solving the last part of this question. So just sit back, relax, and then Watch what I'm going to do right now. So I'm going to read the last part of the question, which is find Q when R equals 6. So I'll substitute the value of R into this particular formula. So that'll be Q equals to 16, 3 multiplied by the value of R squared. What is R? 6. For the second value of R, not the 2/3 again. We are done using this 2/3 to find the value of a constant. So I'll be using the second value of R, that is 6. So that will be Q equals 16 over 3 multiplied by what is 6 squared? 6 squared is what? 36. Are you still following? So if I do that, that'll be 16. Everything over 3 times 36 will give me what? 108. So now 16 cannot really go into 108 directly. But let me get a factor. Let me get a common factor of 16 and 108. And what comes to mind is 4. Okay? So let's try 4. 4 in 16 is 4, right? So let's try 4 in 108. 4 in 10 is 2. 4 times 2, 8. Remember what? 2. So when you put the 2 here, it becomes 28. It becomes what? 28, right? So 4 in 28 is 27. And that means Q equals to what? 4 over 27. 4 over 20. So that means our answer is 4 over 27. So let's check the options we have here. Let's see the one that tallies with what we've got in here, 4 over 27. And obviously it's option B. And that's the correct answer. I'm sure you've learned something in today's class, and I can't wait to see you in my next class. And until then, bye.